Yeah. So, hey everybody, I'm Paulo, one of the developers in charge of maintaining BigBlueButton's real-time communications infrastructure. On this summit, we were covering an old issue we had in BigBlueButton, which is basically the existence of the listen-only mode. So, the origins of the listen-only mode aren't really an UX idea we had or something like that. It's just a mitigation to a technical limitation we've always had, basically. So right now, microphones are resource intensive in the server because we use an MCU topology which actually mixes every microphone stream in a BigBlueButton server. So mixing is CPU bound and CPU expensive, and that doesn't scale well for meetings with a large number of users or servers with a large number of users. That's why the listen-only solution was introduced as a mitigation, because it uses an SFU topology, which just forwards WebRTC streams around, no transcoding required or anything else. So that's way cheaper. The problem with that is that the UX experience is actually truncated and unfamiliar for end users that choose to join as listen-only, for example. It's pretty hard to switch between modes. User feedbacks actually corroborate that. A lot of user feedbacks emphasize that that separation is confusing, which we all agree. So our plan of action to actually try and improve the situation is we've come up with an intermediate step which tries to keep FreeSWITCH, which is the media server in charge of mixing stuff and dealing with microphone in the loop, because we depend on it for a few things like dial-in, telephone integrations. Maintaining it also guarantees a smoother transition in the short term. We'll still save bandwidth because only one stream will be sent around the phone and through users. And of course, a fully SFU-based audio solution can and will be explored on the road with different benefits like audio quality, etc. But that's for later in the future. We've worked on a proof of concept this summit, where microphones will have a built-in listen-only mode, which is transparent to the end user, so the end user actually won't know what's happening, and it's all backend. The underlying premise for that proof of concept is that it's rare and not useful to have many active talkers concurrently, so 10 people talking at the same time isn't really a use case scenario. 2 or 3 maybe, but usually you have a presenter or 2 people in a conversation and that's it. So if you have 200 people in a meeting, most of them will be inactive as far as voice activity is concerned. They will be just spectators. Based on that premise, we've laid out the proof of concept as is shown in the slide. So there are 2 triggers for this proof of concept. So first one is microphone inactivity, which for the sake of this prototype is basically the mute state. So when a user is muted, what we actually will do in the prototype is hold the channel in FreeSWITCH, which means CPU usage is basically 0 in FreeSWITCH for that channel. And I'm not talking about the mod conference hold, I'm talking about the channel-wide hold. That's why the CPU usage is 0 out. And then when that happens, so microphone inactivity is detected, the channel is held. In the server side, we'll switch the user's inbound channel, so what he's listening to a server-side listen-only channel, handled by MediaSoup with a global audio bridge into FreeSWITCH. For that to happen, we had to extend MediaSoup to actually be able to change the consumers, producers on the fly, because we want to avoid renegotiation when doing that. So the experience wouldn't be truncated and would be faster. So no renegotiation needed, all server side. And the second trigger is microphone activity. So for example, in this prototype is the unmute action. So the user unmutes himself. What happens is that his channel is lifted from the hold we put before in FreeSWITCH. So his voice is reactivated in the conference, and we toggle the listen-only channel off in the server side. So folks will get back normally to the way they were before. And the graph here pretty much explains that there is an open issue in the open source repository, which details the solution a bit more, the proposed solution. And so we've done a prototype of what I just explained. There's a pull request open targeting BigBlueButton 2.7 with a few pending things, but the idea is that it will be behind a feature flag. So in an experimental fashion, what that PR does is that we can see here a small test we did just today, which is based on in the environment with 2 virtual cores running at 2.4 gigahertz. There are 16 audio channels, so 16 users using microphone, not listen only, because listen only isn't a thing anymore, and just 1 active talker. On the left here, on the left, we have the new experimental mode, and on the right, the default mode, so BigBlueButton's default, FreeSWITCH audio microphone. We can see that with the new proof of concept, we have the peak of 11% CPU usage, so under 1% per channel CPU usage. And on the right, on the default mode, we have 1.70% GPU usage per channel, a peak of 27% CPU usage, so way higher than the new experimental mode. So new mode uses roughly 40% of what we currently use of CPU on the server side. In the best case scenario, of course. So that basically scales with the number of active talkers, unless we do something about it. So that's basically the pull request is there. It's mostly working. Cursory tests demonstrate that there isn't any impact on switching channels regarding quality and integrity of the audio streams. But there's a lot of things we have to do for this to be considered production grade. So first one is we have to come up with a set of heuristics for defining active talker. So what is actually an active talker? Right now we use the mute state, but we can do a lot more with it. So voice activity, voice levels. We can also detect whether the voice activity is just noise or actually someone speaking. We can use user roles to define a priority of activity talkers, because afterwards we have to constrain the maximum number of active talkers we have on the server side, so we don't end up in a scenario where there are 100 people with their microphone open and they take down the server. And there's also better use of MediaSoup's pause and resume features, which the concept doesn't cover, and will allow us to reduce the CPU usage, like shown before here, even further. So that's a lot of room for improvement here. And then we also have to assess that there's no audio quality regressions, because there are some worries that this automatic switching on the server side will maybe cause audio cutoffs, jitter buffer accumulations, etc. Mainly when holding channels. So we have to make sure we won't actually make the audio quality worse than it already is. And then after all is done and we've validated that, we need to review the client-side UI, remove every reference to the listen-only mode, so the end user can just have a normal experience like any other conferencing tool, which is just joining the conference, enabling microphone, muting and unmuting. No need to choose between modes or switch back and forth. So that's it for the listen only part and phasing it out, etc. And there's a bonus round, which we've also worked a bit on earlier this summit, which is replacing Corento as the recording adapter. So Corento is still used as a recorder for video and screen sharing streams. That's a legacy requirement when we migrated from Corento to MediaSoup. So we've come up with a new application just tailored for recording, which is called BigBlueButton Recorder. It's a Python-based replacement. Python is on this open source WebRTC toolkit, very good one. And Artur Prochenko did the heavy lifting here. He implemented most of the initial version of this recorder, so kudos to him. The current version of the recorder has been integrated into 2.7's build. It is behind a feature flag, so probably we'll have docs for that once the first 2.7 alpha is released. And this summit, we added a few things like Prometheus instrumentation, so we can access performance metrics. We introduced configuration overrides, a bunch of stress testing scripts, so there's automated stress testing scripts we introduced, which are not really dependent on BigBlueButton's infrastructure, so they are light to run. And the next steps will be continue with stress testing, come up with performance improvements. We need to come with a set of scripts so we can verify quality and integrity of the generated capture files. Maybe when compared to Corento, so the idea here is to actually test both concurrently on test servers, demo servers, and compare the outputs and find regressions in the new recorder and make sure it's production grade. And then we have to support H264 afterwards, so as well. So there's a lot of work to do here as well, but it's looking good. And that's it on my end.
All right. Thank you very much, Paulo.